Field Trips features real field stories told by real ASCE members.
I'm Sean Ahdi. I was once a student, a grad student, and at UCLA, and I also was an intern for a small but mighty geophysics firm called Geo-Legend, based out of Corona, California, working on a project for the U.S. Geologic Survey, where I subsequently worked many years later. It's a fun part of the story. Our field trip story today is about doing near-surface field geophysics, SASW, MASW, linear and two-dimensional passive array systems, where we set some geophones on the ground, which are little sensors that listen to the ground's vibration. Hit it with a hammer, the waves travel across the ground surface, and you do some fancy math that I'm not smart enough to understand, and you get a profile of the ground, the wave velocity of the traveling wave, the shear wave velocity profile from depth going downward, which is used commonly in geotechnical earthquake engineering and engineering seismology applications for understanding how much the ground will shake given a different type of soil or rock at your site in a future earthquake. So the background is important because we're at a park. It was a nice day in Santa Barbara County in the summer of 2011. It's been a while. I was working for Geo-Legend. I was just turned 21 years old. And we had a field day where we had two sites, one in the UC Santa Barbara campus, which was beautiful. I had never been there before. People are happy. The sun is shining. They're flying by on their bicycles. And my coworkers were excited because that day we had our big gun, our Geo-Legend was there as a co-PI of the project, Professor Ken Stokoe from UT Austin. Ken's become a fun friend and mentor over the years in the SASW, MASW, understanding near-surface geophysics and inversions. Always good to chat with him. But of course, being young, I didn't know who he was. And then slightly older, but still young coworker of mine who is Italian and fun, but very tough on me, told me that we have to be careful. Professor Stokoe's here today. So everyone was on high alert. Now, the first site went fine, but my coworker was, he was yelling at me. Second site was at this park called Nojokui Falls, about an hour north of the city of Santa Barbara. Just off the 101 freeway, which is it's a really nice place if you ever want to visit. Ping me. I'll drop you a map pin. And we set up another array, and I'm holding this little tiny 3 or 4 pound hammer. We did small hammers for high frequency noise. We did larger hammers, 20-pound sledgehammers. Boom. Over and over and over again. You get tired. So first we start with the big ones, then we go with the small shots after you're tired. And you're hitting the ground with a little metal hammer. You have hit a metal plate, and that dings really loudly. It's all this high frequency noise. And sometimes that plate might vibrate, which induces other noise into your signal that you don't want to have. That makes data processing more complicated later. And Professor Stokoe standing over me, and he says, "You have to hit the hammer just right." He grabs the hammer from me. Ding. Make sure it only makes one contact. No double bounces, no multiple contacts, no plate vibrations on the ground. And we have a picture to show for it with the orange vests on. It was a great day. And that strange thing is you never know when you're in the field. That job was not my dream internship, but I was crying after the first 2 days of 16 and 17-hour field days earlier in the summer. But it opened my career up to field work, geological, geotechnical, geophysical. And then fun fact is 3 years later, as I started grad school at UCLA, I was using all of that data from that project, which was the ARA project, ARRA, USGS. Alan Young was the PI with Professor Stokoe, and Tony Martin, my old boss at Geo-Legend. So if you're interested in near-surface geophysics or their application to geotechnical earthquake engineering, get out in the field, hit the ground with the hammer, drop me a note, and happy to talk about it. Cheers.
Field Trips is a production of ASCE and the Geo-Institute.